SA Water Innovation was established from SAW to build a center of excellence in Adelaide, South Australia, to develop and implement water remediation solutions that are environmentally sustainable. As background for the Stormwater Management Authority, this SA Water Innovation video on preventing water quality crises, not just responding, focuses on our circular water infrastructure platform, covering stormwater.
This video details the SAW Central Coast Council Long Jetty 19 report. SAW was initially engaged in July 2022 to provide a stormwater solution for the Tuggerah Estuary's stormwater trial. In February 2023, we focused on preventing hydrocarbons from entering Tuggerah Lake at Long Jetty 19. This report covers 12 months of actions and testing results.
Our customer value proposition offers local governments a sustainable and reusable solution. It captures over 10 times its own weight in pollutants and protects the environment from dangerous hydrocarbons. The solution reduces waste, eliminates environmental remediation costs, mitigates legal and reputational risks, and protects land and marine ecosystems.
The Tuggerah Lake's Estuary Stormwater Trial was a proof-of-concept project to enhance stormwater quality in Tuggerah lakes and estuaries. The project was initially deployed at the Stormwater Inlet, at the corner of Shaw Street and Lucinda Street in Killarney Vale. Our stormwater solution is a preventative treatment and filtration system designed to remove hydrocarbons from urban stormwater runoff, thereby improving water quality. It captures hydrocarbons, heavy metals, and PFAS, while also collecting valuable data for scientific analysis and pollution source tracking. The circular economy model for our sponge involves several end-of-life products. The granular cell technology forms the core of the sponge. Used products are reconditioned, and captured oil is removed, recycled, and reused. Unusable or damaged sponge is refined into carbon black, hydrogen, and low-emission fuels.
Our environmental impacts include reducing the carbon and material footprint of the product and reducing captured pollutants. Our process involves no landfill or incineration, instead focusing on reuse, recycle, and repurpose, which eliminates land contamination and achieves a CO2 reduction. This protects environments and ecosystems from hydrocarbon contamination and improves human life, farming, and fisheries.
Let's review the methodology used at the Long Jetty 19 location.
Our hydrocarbon capture method involved installing absorbent material in the storm drain's termination point. Following sufficient rainfall, materials were retrieved and booms were replaced. Samples were prepared for THPGC analysis and analyzed qualitatively. This process enables risk mitigation by filtering hydrocarbons and toxins from the water.
The timeline began with the first booms installed on February 23rd. The booms were changed out on March 12th, significantly earlier than the expected 6 weeks, due to the rapid rate of hydrocarbon capture. Sponge and water samples were collected at various intervals and sent for analysis, with additional sponge samples sent in August 2023.
Water samples were collected before and after the booms, and at a control point off the jetty in June and July 2023. Hydrocarbon samples were collected from the surface. Heavy metal and PFAS samples were collected following directions provided by the University of Newcastle. For sponge sample collection, the sample soaked in liquid was extracted in an organic solvent and analyzed by GCMS at Microanalysis Australia. The summary identified various hydrocarbons, natural oils, fatty acids, and cosmetic ingredients. For vessel deployment, we deployed a collaborative AWS research vessel at the designated location to establish a controlled, sheltered lagoon environment. This facilitated uninterrupted acquisition of sequential water samples. The use of oil and water sensors achieved continuous collection of hydrocarbon concentration data. In OIW sensor collaboration, digital sensors, calibrated by AWS technicians, measure, display, and log the ppm of oil detected in water. The dissolved oxygen sensor utilizes fluorescence lifetime technology for accurate, stable, faster, and more convenient dissolved element measurements. Sensors are fixed to the vessel or used as handheld units.
By utilizing weather data, we tracked the impact of weather conditions on hydrocarbon level readings. Analysis of data from AWS digital twin sensors showed a correlation between hydrocarbon flow and wind direction. Specifically, higher hydrocarbon readings were observed in the channel when the wind was blowing toward the east. We will now review the results of the Long Jetty 19 report. All reported samples are water collected from LJ19 for testing of hydrocarbon, heavy metals, or PFAS. Samples were collected using methods advised by the University of Newcastle. 4 samples were received for the full analysis. The analysis of retained chemicals in the gyroid sponge shows components consistent with diesel, which is made up of 95% saturated hydrocarbons and 5% aromatic compounds. Octadecane, a component of diesel fuel, showed a relative abundance of 26.02% and a compound per sponge weight of 129.66 grams per kilogram. Further results show compounds such as fatty alcohols and fatty methyl esters. Oleic acid, a component used as an excipient in pharmaceuticals, was present at 8.36% relative abundance and 41.69 grams per kilogram. Other chemicals captured by the gyroid sponge include anti-scaling/cleaning agents, acid mine drainage components, and fluoropolymer coatings. Chlorinated hydrocarbons, used in many chemical products, were found at a relative abundance of 17.76% and 88.49 grams per kilogram. Additional chemicals retained by weight in the gyroid sponge include various fatty acid methyl esters and macrocyclic lactones, commonly found in soil microorganisms. More retained chemicals include compounds related to floor polish, plasticizers, and industrial solvents, further highlighting the diverse range of pollutants captured by the sponge. The results also identified other pollutants, specifically fatty acid methyl esters, as part of the retained chemicals. Laboratory analysis utilizing gas chromatography mass spectrometry confirmed traces of PFAS and heavy metals in the sponge samples. The compounds retained are consistent with diesel fuel and its additives, composed of hydrocarbons with 18 to 34 carbon atoms per molecule.
The hydrocarbon analysis, conducted by the University of Newcastle, showed that, while hydrocarbons were the largest amount of toxins collected, other dangerous materials were also captured. These toxins are harmful to the local flora, fauna, marine life, and birds.
Total petroleum hydrocarbons, or TPH, include volatile and extractable hydrocarbons. The diesel and fuel oil components range from C10 to C28 aliphatic hydrocarbons and aromatic hydrocarbons. Hydrocarbon readings before the boom were around 23 ppm, but peaked up to 220 ppm in the drain. After the boom, the reading dropped to 11.9 ppm. The residual level is due to tidal flow and existing background hydrocarbon levels in the lake water, which are reduced by the filtering.
The PFAS analysis results highlight the presence of these chemicals in the water. A sponge sample from Long Jetty 19 was tested after 2 weeks of use for captured hydrocarbons, heavy metals, and PFAS by type and weight to determine the toxins being captured. The PFAS sponge analysis confirmed 2.93 grams of PFAS retained per kilogram of sponge. The heavy metal sponge analysis results show that the gyroid sponge retained significant amounts of zinc, antimony, and manganese.
Let's summarize the key findings of this report.
The current hydrocarbon data likely represents a minimum level of pollutant release due to fluctuating flush releases. Significantly greater pollutant release should be assumed, which can be better estimated with longer monitoring periods and broader area coverage.
We partnered with Amazon Web Services and ARQ to develop sophisticated data capture and analysis using a digital twin. This facility was deployed at Long Jetty 19 to collect data every 5 seconds, before and after the gyroid filters.
SA Water Innovation, with partners like the University of Newcastle and AWS, offers expertise for laboratory testing and upstream analysis. We can assist in developing requirements for securing funding to capture, test, identify, and remediate affected areas at Long Jetty 19 and 1516.
Analytical summary. The hydrocarbon data represents minimum release levels due to, quote, flush releases from sources influenced by hydrological changes. Greater pollutant release should be assumed, and longer, broader monitoring is recommended, particularly in low water exchange areas where pollutants may accumulate.
Since the sponge is optimized for hydrocarbon capture, the retention of PFAS suggests differential remediation is needed. Recommendations include fingerprint analysis of captured hydrocarbons, upstream exploration for the source, and positioning guyoid sorbent material upstream in stormwater drains.
We will now cover additional activity conducted.
We provided Central Coast Council with 4 triage solutions to stop hydrocarbons from entering Tuggerah Lake. Booms were placed across stormwater channels at Shaw Street, Long Jetty 15, 16, and 19. Water samples and OIW sensor readings were collected, and the booms were stored for future analysis.
OIW sensors were used to record hydrocarbon parts per million. Readings were taken on August 22nd and 23rd, 2023, after overnight rain at Long Jetty 15, 16, and 19. The accompanying videos show the readings as they were captured. These videos demonstrate the OIW sensors recording hydrocarbon ppm at the sites. The readings were taken after rainfall on August 22nd and 23rd, 2023, at Long Jetty 15, 16, and 19. SORR replaced and retained the hydrocarbon-soaked booms for potential reuse or recycling. These booms are stored until a decision is made regarding analysis, including potential pollutant fingerprinting to identify the source of pollution. This slide displays visual evidence of the data collection and site triage activities, showcasing the deployed booms and sensors used to mitigate pollution and gather critical information. Thank you for watching this video. We are a team of motivated environmental and purpose-based individuals dedicated to sustainable solutions for water quality crises.